Hi, everybody. I'm happy to be at the Innovation Summit of Secure Power and talk to you a little bit about how we are reimagining the industrial world and what does it mean to some of our customers and also to you. Obviously, representing the company, I also want to talk about what's on our mind when we're talking about life is on, or when we want to empower all of us to make the most out of the energy and the resources that are available, ensuring that life is on everywhere for everyone and at every moment. Life is on means for us a secure supply of power for everybody and a secure supply of digital. Just imagine working from home at the moment and you don't have access to digital. What would that be? Kind of a disaster. Your kids cannot do the homework, you cannot do work. I mean, then all of a sudden you're stuck and can basically do nothing than reading a book, talk to each other, and so forth. So that's critical going forward. Now, there are huge disruptions in the market when we talk about an energy transition that was traditionally from generation to transmission, distribution to usage. That has totally changed because users are also generating electricity, and you can imagine how that disrupts the market, while at the same time we have the deployment of digital solutions in the industrial world as well as in all end markets. Those two combined will make a big difference in the markets where all of us are active. Now, one of the things that has not changed and will continue to be important for our customer is the topic of efficiency, obviously for a sustainable future, but also in respect to having power available in a very secure and continuous manner as you have mission critical processes that you run in your facilities, while at the same time you'll have the pressure to decarbonate as much as you can your operations. So that's very critical. Now, that's on the electricity side, but then there is also the process side that we can think about. How can we make a process in itself more sustainable? Meaning, how can you produce the same with a less input of resources, be it material, be it the usage of capital, or be it the usage of electricity, for example. And that's achieved by driving asset performance, by driving productivity with digital tools, and we'll talk about this in more detail, and with that, of course, gaining efficiency for your overall operations. So we got to make it possible to reduce the CO2 footprint by 50% by 2040. 3 simple steps. Number 1 is we got to save energy and make buildings and other things that are on stock, if you wish, more save energy, 30 to 50% possible in our view. Secondly, electrify. The more we electrify, because we believe it's one of the best sources of energy, we can reduce the carbon footprint. And thirdly, of course, decarbonize. So drive renewables like wind and solar aggressively forward from 6% today to 40% in 2040. Those 3 simple steps will make it possible to reduce the carbon footprint globally by 50%. Now, on the digital side, of course, in the past, there were bottlenecks of communication, there were bottlenecks of storage, there were bottlenecks of bandwidth. All of those have gone away in the last couple of years, really accelerating some of the digital developments, in particular in the industrial environment, where you have a lot of data, where you need a lot of bandwidth, and most importantly, where you also need this in real time. And if I talk real time, I'm not talking about seconds. I talk about milliseconds, microseconds, where you need to make decisions and be able to control facilities to drive that forward. Now, the development of AI has also helped us tremendously in respect to driving efficiency and productivity forward, as I'll explain to you in a couple of examples going forward. Now, we see really 4 major transformations or inflection points in the industrial world that are relevant for many, many of our customers, where we can also play a key role. And I'd like to talk about those four and give you some examples, and then you can find out also how it can affect your operations. The first one is we see a convergence of energy and automation, as I said earlier. Why is that very important? It is important in industries that are very energy intensive in the core process. Now, many times people would have separated in the past energy management or the supply of energy into the process and then controlling the process. We believe that you can drive down significantly the usage of energy if these two solutions come much, much closer together. Let me give you a couple of examples in a minute here. Now, one of the things that has also changed with the current crisis, and we see this at many of our customers, is not only the convergence of the two, but also the resilience of energy availability, and with that also being able to drive your process through also difficult times where you have power outages and so forth, to be able to control the process even better. So here's the first example, a pharmaceutical plant in Italy. As you can imagine, during the crisis, one of the things that is absolutely critical is that in these plants, they run on a continuous basis with a constant supply of energy, if you will, to assure that there is continuous output. So next to the automation challenge that we had to bring this in an industrial 4.0 setting, we wanted to make sure that there is also secure power with it in order to assure best output possible. Of course, also deploying then technologies like augmented reality to make sure in case something goes wrong that failures can be fixed immediately without the intervention of too many people on site. So one more example out of a different industry is metals and mining. So in the mining industry, my next example, a lithium mine in Argentina, where the total investment is 400 million with that customer, and they're producing 20,000 ton of lithium carbonate. And of course, the challenge is at an altitude of 4,000 meters. You can imagine how thin the air is, and that your equipment run very smoothly. And with that, it is critical that also in case you have troubles with supply of power, that you do bring security to it, and to be able to continue to drive the process also through times of power fluctuations that you may have. So a complete solution here from Schneider to the customer, and it's important to note, of course, and he says it here in the comment, it's not only about the reduction of capex, but also to be able to have a good output at this high altitude. Maybe a third example, again in the mining business here in South America or Middle America, where in a very remote location, and we see this also quite often, where you may not have full secure power available at all points in time in your manufacturing process, and also here we bring a pretty large installation of drives that run with our secure power products together to ensure production over many years. So you can see, very critical to bring power and automation together to secure output and to increase productivity, while at the same time being able to reduce your carbon footprint. Now, the second thing that we see that is very critical is how do we connect from the endpoint to the cloud? Now, you may say, well, this is an old story. It is to a certain extent, but if you move into industrial applications where you don't have one endpoint in a plant, you have a couple 100,000 endpoints where you need data in real time available in the cloud over a long period of time. you can see all of a sudden the technical challenge that's behind it. Now, I'd like to talk a little bit about what's the advantage of the flawless connection that you can have from the endpoint to the cloud, and it does require some technologies, because many of the facilities where you want to do that, they're already a couple of years old. So one of the examples I'm going to share is with one of our facilities in France. That is a factory that's more than 50 years old, and we've upgraded this significantly in being able to bring as many data points to the cloud, and then have applications run on the machinery, on the line, to improve the uptime, to improve productivity, to improve the mean time to repair in case something goes on. And I can tell you a whole story, but maybe we'll have a short video that shows you what's going on in our plant here, and how we are connecting data points to the cloud, and then have applications run on them to create value for us in this case.
Whenever you talk about the factory of the future, people wonder whether these factories will still need people, what job these people will do, and how they will do them. Here at our plant in Le Vaudreuil, we already have a pretty good idea. The augmented operator is one example. Augmented reality gives operators a superpower of sorts. They can see through machines and know everything that is going on inside them. Before, if a machine broke down, the operator would spend a lot of time troubleshooting. With EcoStruxure Augmented Operator Advisor, the operator scans the affected area of the machine, and digital information is superimposed on a real-world image of the machine. The operator can then access all the necessary information on a tablet, from the location of the malfunction to the condition and technical specs of the part, and even read the user documentation. This reduces the time spent on troubleshooting by 30% to 50%, boosts machine productivity, and makes the operator's work safer, because it limits the need to come into contact with machine parts and electrical panel. Operators can also use augmented reality when running a machine. They can see the equipment status and plan ahead for maintenance, which increases equipment uptime. The part that required the most work was modeling key areas of the process so that they would be recognized when an operator scans a point of interest. The points of interest are indicated at strategic locations and connected to an edge box that stores all data in a local cloud and sends the information to a tablet.
I think this was a pretty cool video on our facilities, and we've deployed this in 80 to 100 of our own sites. And as you can imagine, the heads of the factory, they're not eager to invest if there is no real return on the investment, because usually that's what we're driving them for, to have a return on the invest and increase productivity. So well done. So that was a simple application in our factory. If you want to drive this all the way into the high end, I brought you another example here of one of our customers who has a couple of big assets in the North Sea. It's one of the largest oil fields in offshore, producing 690,000 barrels of oil a day. And the beauty of that is that we have an 80 to 90% reduction in CO2 footprint compared to other deployments that are out there. Now, the significance of this one is that this oil platform was designed with our 3D design software of Aviva, and but it didn't stop there. We are now able to, from onshore, look at the digital twin of this platform here, and we're able to remotely operate it for several weeks before we need to before the customer sends a team on site to do the respective maintenance work, where you still, cannot work with digital tools, but where you need a hammer, a screwdriver, and other tools to do the necessary maintenance and repair. But a significant reduction of offshore exposure for the customer, thus reducing exposure for them, increasing safety, and with that also delivering a much higher return. This site was inaugurated by the local prime minister a couple of months back, so quite a nice deployment. You can see the significance from a low-end application where we just use a little bit of data to predict how a machine is functioning, to a remote operation of a very, very complex facility that you have here. And it's independent on what end market we're talking about, but the capabilities are there and will become even more important after the current crisis, as you can imagine, because many of our customers are thinking about how can I remotely control and operate my facility or do maintenance work with as few people as necessary and control as much as possible remotely to keep the respective distance to the people who need to be there on site. So that's a topic that we believe will explode in the next couple of months and years to come. And I'll talk a little bit in more detail on other applications later. The third point that is of relevance, and you've seen this already with the connection to this oil field where we used our design software. And we believe that if you look at the value chain of a facility or of an asset that you usually design, then you build it, that usually takes a third of the time, and then 2/3 of the investment, and 2/3 of the investment that you have is during operation and maintenance. And time-wise, that's where you are stuck with the assets for many years. Now we've been able with AVEVA to totally digitize that process from design of a plant to the building, the operation, and the maintenance. And the relevance is, of course, that in the past, those were static pictures of the design and of the build. And I show this here with a little bit of a control center, if you will, where we are showing the end-to-end digital thread. Here in the middle, where you see that little picture, you have the 3D design of a pump station that is in your plan that you had designed some time back. But now this is a real representation of the pump in the field, and you get real-time data to it. If you have real-time and historic data to that respective pump, if you wish, you can get operational improvements done and tested digitally. You can run predictive or prescriptive maintenance on this pump, and context sensitive. With a digital twin, you position your mouse pointer, for example, on a certain part of the plant, and all the operational data comes with it, and that has improved the possibilities to bring up productivity with our customers tremendously. Of course, many times we are talking about a brownfield installation, and many of the digital enablers are not there. But this can be achieved today by 3D scanning of a plant, for example, easy way of connecting what I said earlier from the endpoint to the cloud. So you bring data where you actually need it, and drive this forward. To give you some examples here, on the left-hand side is when you operate and maintain an asset. Could be a pump, could be a compressor, could be anything that operates on a daily basis. It generates data. You can see that here. These graphs on the left-hand chart, a little bit the lower two buckets there. Data is generated here in this example. These are vibration data that are fed back into a life cycle asset performance management system, and you can actually start detecting something that goes wrong prior to it actually happening. And then you take certain actions to it. I bring a couple of examples in a minute. Secondly, if you look, for example, at a design that you have done on a 3D tool, and all of a sudden you furnish this with real-time data, it becomes what is called in the industry a digital twin. And let's make no mistake, there is a difference between a digital representation, that means you've designed something digitally. That's not a digital twin. That's a digital representation of something you want to build. After you've built it and you furnish real-time data from the real asset into this digital representation, it becomes a digital twin because it uses the real-time data from the actual asset that's there, and that causes quite a few possibilities to optimize. Let me share some examples here, what advantages you can generate. So we have a nice example here from British Petroleum, where they actually said we have revolutionized their process by moving some of the things that they had on site to the cloud, where we could run optimizations of their total supply chain. So the total supply chain of British Petroleum that has usually taken on a simulation 7 hours and it's a very complicated model, as you can imagine, can now be run in 3.25 minutes. And with that, of course, you can calculate more scenarios of how you can improve your supply chain. In this example, for example, they would have some feedstock or some crude that they had purchased somewhere, and they need to simulate in what refinery this specific quality of crude could be refined in the best way. Now, this requires, as you can imagine, quite some simulation. If the simulation takes 7 hours, the ship is going to be waiting somewhere for a long time, right? If it only takes 3.5 minutes, and you run several simulations to come maybe up with the best result, it's a huge saving for the customer. And you can see that 70 cents per barrel. That's a lot of money. It's a lot of money when the barrel of oil only costs $20, right? So humongous saving for the customer. A second example here is another oil company. They are deploying in a lot of critical assets in their plant, which are usually the rotating equipment. So this can be compressors, this can be turbines. And what we do is, as you can see on the top chart, right-hand side, we take all the sensing data and connect these turbines, take historic data to them, and with our predictive maintenance tool or software, where we have quite some AI deployed, we can predict failures before they're actually happening. So a couple of parameters here for this customer, where in the first 12 months of deployment, we had 100 catches. A catch is you detect a failure before it actually happens. And that, as you can imagine, in a rotating equipment is quite important, because you can actually have a small fix, as you can see here in this rotor blade on the lower right-hand chart. You can fix that blade before it starts flying around in a very highly complex turbine, and it destroys it pretty badly if it runs loose in there. So quite a nice example. But it's not only on rotating equipment. We do the same for power. And here an example of a BASF. This is from a facility in Houston, if I'm not mistaken. We're measuring a couple hundred variables on their power supply to see what and how safe and how good the actual power supply is for the facility. In the same facility, by the way, they run the software that I've shown on the slide earlier. So a customer that had really deployed our asset performance management in all aspects of their operations, increasing efficiency and productivity. Let me come to the last point where we go from a side-by-side optimization to an integrated company management. That is absolutely critical after the pandemia, as you can imagine, where we see a lot of changes and shifts in the supply chain, where people may rethink their total supply chain, where they may go into more facilities in more places, as opposed to having one large facility somewhere that's going to be shut down, and they need to worry about how they can continue to deliver to their customers. So it's a very hot topic with some of our customers, and I'll go right into an example to show you what it could mean. Now here we have a customer in Abu Dhabi that has 13 operating companies, if I'm not mistaken, all of them with different joint venture partners, and they said, I'd like to know in one location or in two locations globally what's going on in my facilities. So we have, within 6 weeks, built up this control and operations center where we brought together more than 150,000 data points out of their facilities in the first run to show on this huge video wall that is 50 meters long, 3 meters high, whatever is going on in their facility. So they have total visibility, and once the data and the platform is there, you have it visible, then you run applications of asset performance management or scheduling and so forth to improve your operations. So this has been quite a sight. Now this has been kicked off 2 years ago in the oil and gas industry, and meanwhile we see this coming up all over the place. Even cities that are newly developed here, smart city development in India, where we've connected in the data center also more than 100,000 I/O points. And from a variety of different things, be it waste management, be it security, be it water and so forth, to be able to give in one point in time and in one location somebody a total overview on how the city is operated. Now, if it's possible in a city, you can also do this then in many other facilities. A city could be also a fleet of buildings, and so this is something that has been totally taken off for us, and we have more templates, if you will, that will come up where you can do that. So something to watch out in the next couple of days is how we will do this for data centers or fleet of data centers to be able to optimize that. Now, if we recap, the 4 integrations that we've seen, you've seen a lot of connection, and a lot of connection means also a lot of danger. And that's why it's not only 4 inflection points or 4 transformations, but 4 plus 1, if you wish. And the fifth one is, of course, in respect to cybersecurity. When I talk cybersecurity, I'm not only talk about the IT side of things, but also the OT side, the operational technology. When you go into the shop floor, when you go into the plant, when you're at the machinery, usually you have IP interfaces, you have USBs, you have operating systems that may be a little bit older, that could be quite vulnerable. For that, it's important that we're offering a comprehensive package of OT and IT cybersecurity services to our customers when it is about assessment of existing plants, no matter what equipment is in there, and then come up with a proposal on how to design a proper, secure site implemented together with the customer. And then, of course, it's not this is not a short sprint, but it's a marathon. It's a continuous marathon, if you will, to keep the site safe, not only in respect to technology, but also secure processes and also products and people that you're deploying there. So very, very important for us to drive this forward, also with alliance partners all over the place, because cybersecurity is something where you need to work together with a lot of people. Hey, that brings me to the end of Digital Industries Reimaginated after the crisis. Maybe 5 key considerations for you to take back. How can you leverage the combination of energy management and automation to increase resilience, to increase efficiency. Secondly, how do we make use of all the digital data points that are there, bring them to the cloud, have applications run there again in order to increase efficiency, increase safety, and drive down the usage of resources. Then, of course, if you want to digitize your complete operations and have a digitally visible, furnished data to it, you'll have the end-to-end digital thread that brings great advantages because you can simulate a lot of things, you can test a lot of things before you actually go into the plant and deploy them, and then make sure that the savings are with you. And fourthly, you know, is when we're talking about the integrated total company, we believe that the future of supply chain really depends on the resiliency, how things are connected, and it is important to have a centers of visibility into your complete supply chain to be able to make quick decisions where you have disruptions in order to furnish your customer better than your competition. And of course, we shouldn't end without a note on cybersecurity. Again, it's very critical also in the OT space. With that, I hope I've given you some insight how we reimagine industry after the crisis, and many of our customers are working on it. They've seen some of the things early, but you can see how it converges. A pleasure, and I wish you continuous nice event with the colleagues of Secure Power. Thanks very much.